So let's solve this. Problem number 6. So this is a problem where you need to have a strong physical understanding of what is happening when we have this kind of complicated pulley system. So there are a few things that you need to understand in this problem, which will be very helpful in solving all the complicated problems involved with one or more than one pulleys. Okay, so the very first thing what I want you to understand is the movement. Say when this is moving by an amount x, as we discussed earlier, when this moves by an amount x, how much will this object be moving? That's what we want to know. Say if this moves by an amount x, so what happens is that this whole cable will be moving by an amount x. If this moves in this direction, this whole cable will be winding and will be going up, unwinding, and this block will be moving down. And if you observe closely, you can find that this will be moving down by an amount x by 2. It won't be moving down by an amount x, it will be moving down by an amount x by 2. Okay, so that is the very first thing that you need to appreciate. Only if you understand this concept we can move further. Okay, if it was a single pulley, the amount moved is x and the amount moved will be x here also, but this is a combination case. So here if this moves by x, this will be x by 2, which basically means that if this block is having an acceleration a in this direction, this block will be having an acceleration a by 2 only. That is a basic thing that we want to grab from this particular problem. So you need to try all the combinations before writing this, because this is the critical point. If you go wrong at this point, your answer will be completely wrong. And now there is another thing that we need to concentrate on. So we are all familiar with the pulley arrangement that we normally use in case of wells. Okay, for fetching water we'll be using the pulley system. So it can be something like this. So you have a well, okay, so there will be a rod connected here, another rod here, top also you are going to have a rod, and then there's going to be something like this, and you have your pulley, and there will be, okay, the one connected to the bucket, the other one is in your hand. Now you can think about this. Let the weight of this is weight of the bucket is 5 kg. Okay, the water is there in the bucket and it weighs 5 kg. So you can see that this cable will be under a tension of 5 kg into 9.81. Okay, so approximately 50 Newton is what this cable is experiencing. If I'm holding at this point, this cable will be experiencing 50 Newton force, because the weight of the bucket is 5 kg, which is pulling it down. And what about this side? If you want to lift that 50 Newton, you'll be applying a 50 Newton here also, right? You are pulling it, so you'll be pulling it with 50 Newton. The bucket will be pulling it with 50 Newton. So this is what the condition is. Now if you try to plot the free body diagram of this part, okay, how will it be? The free body diagram will be, you have this T equal to 50 Newton here, T equal to 50 Newton here, and you can see that this rod, connecting rod, will be also under tension. I'm calling it as T1. So in this case, if my x and y system is something like this, what will be sigma Fy? Equal to 0. What will be the condition? T1 equal to T plus T, that is 100 Newton. Okay, so that's basically what we want to use here. So you can see here, in this case The tension in this cable, say I'm assuming the tension as T here. Okay, tension is T here, T here. What about the tension in this part? It is similar to this case. The tension in this part will be 2T. Okay, that is another important aspect we need to consider. So there is T here, okay, just like this case. So this cable will be experiencing 2T, just as in our well pulley case. Okay, so this is the diagram that we are going to handle. Okay, so this also we are going to use the tool free body diagram, and we can just solve it. So let's try plotting the free body diagram of each object. So I'm starting with the free body diagram of, say, A. So what will be the free body diagram? I'll be having the block, okay, and the weight of the block is acting downward. So we forgot to write down the available data. The data available to us at this particular point is MB is equal to 100 kg, MA is equal to 20 kg, mu A, coefficient of friction between block A and the surface, is 0.2, and we are asked to calculate the acceleration and tension in the cable. Okay, so let's try that. So we have the weight of A, that is 20 g. Okay, 20 is the mass, so 20 g is the weight. There will be a normal reaction between the surfaces in contact, so I'll be having a normal reaction N, and there is a tension T in the cable, and we know that this is moving in this direction, so acceleration A in this direction. Is there any other force? Yes, the frictional force, because these two surfaces are in contact and this block A is moving to the right, so the frictional force will be to the left, which is mu N. So we have the value of mu as 0.2, so basically 0.2 times N. So this is the free body diagram of A. Similarly, we can have the free body diagram of B. So how will it look? The free body diagram of B will be something like this. The weight is acting downward. The weight is 100 kg, so 100 g, and the cable, this cable will be experiencing 2T. That is a concept that we explained here. It's not T, it is 2T. So this is 2T. Okay, and this one is moving down with an acceleration A by 2. We need to be careful about this, and it is downward. Here it is to the right, here it is downward. Now we are going to use the equations of equilibrium. We have either the static equilibrium or dynamic equilibrium. As these components are in motion, we can use the condition of dynamic equilibrium. So I need to have some xy system. So I'm considering, say, this as x, this as y, positive x, positive y. Fine. Now I'm going to do it. So first I'm writing, say, sigma Fy is equal to MAY. Okay, so block A, Y is this direction. Now I will check whether this block is having any acceleration or movement in this direction. No movement, it is only moving in the x direction, so this term is 0. Now I can write sigma Fx, sigma Fy. So there is a N acting upward and 20 g downward equal to 0. There are no other forces, so I'll be getting N is equal to 20 into 9.81 newtons. Okay, Now I am writing sigma fx equal to max. So now I need to check the acceleration in the x direction. This is my x direction and I am having an acceleration a. Assumed x direction is positive to the right, acceleration is also to the right, so this is plus a. Okay, now let's see. T to the right, 0.2 n to the left, 0.2 n to the left equal to the right hand side mass. Mass of a is 20, so 20a. Okay, we have the value of n is available, so we can write t minus 0.2 into 20 into 9.81 is equal to 20a. That's my equation number 1. So there are two unknowns a and t, so I need another equation that I can get it from free body diagram of B. So I'm trying that. So here also first I am going with sigma fx equal to max. So I'm looking at the object. This is my x direction. This block B is not going to have any acceleration in this direction. It is only moving in this vertical direction. So this term becomes 0. Now I'm looking for the forces in the x direction. In this particular block there is no force in the x direction at all. So basically means 0 equal to 0. Now I'm writing sigma fy equal to may. So here we need to think about the acceleration in the y direction. So let's see. So this is my y direction. Y positive is upward. This block is having a downward acceleration of a by 2. Assumed direction is upward. What I got is minus. So it is minus a by 2. This is what we need to be very careful about. Okay, ay is minus a by 2, minus because it is in the opposite of the assumed direction. The magnitude is a by 2. Now let's write it. So fy positive is upward, so I have 2t upward minus 100 into 9.81 downward. That's the left hand side, no other forces. Then on the right hand side, mass is 100 kg, acceleration is minus a by 2. So I will be getting this equation as I'm writing it just like this itself. I can directly substitute in calculator and I can get the value. So minus 50a. That's my equation number 2. So now I have two equations with two unknowns. So simultaneous equations, I can directly feed it inside a calculator and I can get the final solution. And on solving this, I'm going to get the solution as T is equal to 239.8 Newton and A is equal to 10.03 meter per second square. So I got these two values, the value of tension and value of acceleration. But this is not the complete answer, because here we can see that the different cables are having different tension. This cable is having a tension value T and this cable is having a tension value 2T. Similarly, acceleration is A for block A and A by 2 for block B. So that need to be written separately. So what I can do is I can have the condition for block A. Okay, I don't have enough place, so I'm using just this portion I'm using. So for block A, block B. So tension in block A, I have the value as T itself, which is 239.8, and for block B, that is this cable, the tension is 2T, that is 2 into 239.8. Similarly, acceleration for block A is the value what I got, 10.03, and for block B is A by 2. So acceleration of block B is half of this, that is 10.03 by 2. So this forms the final answer. So the block A, tension in the cable and acceleration for block. For block B, tension in the cable and acceleration for the block. So this gives the final answer.